Good morning, good afternoon, and welcome to this talk on mobile edge computing. And this is for a report that Sensafili has produced in collaboration with RCR Wireless. And what we're talking in the report is how the functionality that traditionally has been in the core forever, it's moving to the edge, at the same time that the RAN is moving more towards the core. So there is a middle ground where it makes sense for functions to be in order to minimize latency and optimize performance in the use of network resources. This is a very fascinating transition that we are seeing in the wireless industry. And today I'm going to talk to Debashish Purkayastha, is a member of a technical staff at InterDigital, and he's going to share with us his thoughts on how this transition to the edge through mobile edge computing, multiple access edge computing, and initiatives like OpenFog are going to bring to the wireless industry. Debashish, thanks for being with us today.
Thank you. I'm glad to be here.
Okay, to get started, can you tell us what you and InterDigital are doing in this space?
Okay, sure. Very simply, the development of the mobile edge network has the potential to lead us to the next killer app, because there are mainly two reasons. Of course, the first reason is it can dramatically increase the responsiveness of the network, and also give application programmers access to mobile network information, which many of the developers don't have at this point of time. But to go back, our we started a few years back when we identified the need for enabling the edge. And what I mean by enabling the edge is adding capabilities at the edge and define a range of services that can be offered from the edge and taking advantage of the network information as well as user information. So what we did, we started working on edge caching. What it means is storing content at the edge of the network and then enable video distribution services from the edge with a knowledge about, I would say, a more detailed knowledge about what the user likes, what is the user's preferences, because those can be very easily and very accurately measured from the edge of the network. So while working on that, I think we realized that why do we constrain ourselves just to content? Why not move computation as well as storage as a general to move to the edge of the network? So that's what we started. That's when we started exploring about edge computing. So when we started doing that, we started identifying what are the challenges in moving computation and storage at the edge of the network. So the first challenge that we faced was defining where and what exactly is the edge. And we identified that depending on the use cases, the edge may be at the different levels of the network. Another problem with the network edge is the availability of so many different kind of devices and platforms that it introduces heterogeneity. So what we are talking here is heterogeneous devices of different shapes, different sizes, different capabilities, and these devices may be owned by different owners, different network operators, different access mechanism. So with these different heterogeneous devices, it's very difficult to develop application on this kind of devices. And the third is from the developer's perspective now, with so many different devices, different access mechanism, different owners, how can a developer write an application which can run uniformly across all such platforms?
Right, and so this is very interesting, because what we're dealing with is the opportunity to manage traffic in a more intelligent and sophisticated way. But as we do that, we have to deal with a level of complexity that was unheard of before. So we introduce complexity in the network And so what are the advantages here? Because that, from an operator point of view, it's like, well, this all sounds very, very, challenging in some way. You have to deal with all of this. What are the advantages?
Okay, yeah, so the advantages are, I would say, the first and the most important advantage that we think is the improvement or the reduction in the latency. And what by latency reduction I mean, we will see instant improvement in the responsiveness of the applications. So, which will definitely, I think, improve the satisfaction of the customers that the network operators are serving. And besides the improvement in the responsiveness of the applications through reduction of latency, another important aspect of edge computing is, of course, reduction in traffic in the backhaul network. As we know, small cells are being deployed and it is becoming popular, connecting a small cell through that to the backhaul network is very challenging, because that's the bottleneck that network operators are facing: how to run a wire to a small cell that is mounted on a lamppost. So with that kind of bottleneck, what edge computing provides is reducing the traffic. So how it reduces the traffic? Because right now we have the capability to process users' request, the data at the edge, and respond or deliver it back to the user. And as a result, data does not need to travel over the backhaul network. The third aspect, which is also important, is the privacy and security concern. As we know, as our data goes over the network at different places of the internet, everywhere there is vulnerability of our data being, stolen away. But right now with edge computing, as we can process data, we at the edge, we keep the data in a local context. We don't let it go outside or in the internet. So that's also, I would say, many users or many applications demands that kind of privacy and security, where they don't want their data to be available in the internet. So those are the three main aspects from the operator's perspective, and also I think users' perspective, which are the benefits of using the MEC or the MEC technology.
So basically, you introduce some sophistication in the way you manage traffic, but you get much out of it. One thing that I wanted to ask, I think you raised a very important issue, a very important point, is the fact that you can choose. So you mentioned you might want to keep the content local for security reasons, or because the traffic is local, or you might want to choose a different level of performance for an application. But the question is, who is going to decide? Because obviously the first candidate is the mobile operator that decides how to manage traffic based on their network resources, but it could also be the enterprise that decides what content stays local, or it could be the user that decides which rate to have a video, or the content provider that decides what should be the resolution. How do you see that working out? Who can decide, or who will decide, you think?
Yeah, this is a very interesting question, because, yeah, of course, by deploying MEC, we have the options of this traffic management or traffic control. Where does my data go? How far does it go? These are the decisions, as you said, are available to the user, the network operator, and also, say, the application developers or the enterprise itself. So I think right now, what we think is it is a decision that can be application specific or users requirement specific. There is no one decision that, okay, that every time an operator manages or decides. So for example, in certain applications, where, for example, I would say a video distribution service, where the users maybe in that service, the user may be okay to to tolerate certain kind of low quality video, which will allow the network operator to make such decisions to improve the efficiency of their network. So in that case, the network may decide that how much the data rate and that a particular user should be allowed, based on the utilization of their network resources. So, but for example, it may not be possible or may not be feasible in the kind of the video distribution services, like every user coming and saying, I always want an HD quality video. That is not feasible. So in that kind of application, I imagine the control will stay with the network operator. But if we're talking about, say, user data, like for example, my medical records, and say my vital statistics being processed at the edge in a medical application, in that case, it may be with the user, where the user say and attach the parameters or request the network operator, my data should be processed at the edge. And even the user can go ahead and specify, say, for example, which edge server it wants the data to be processed, because it relies that server can provide the security that the user expects.
Right. Well, that's very interesting. Now, you mentioned before that you've been working on caching and basically edge computing for a long time. But what we've seen now is it's an effort, big industry effort to standardize it. There's MEC at Etsy, OpenFog, and different initiatives. And I guess they address the issue of multi-vendor networks. So you need to have multiple vendors. So you need to have some interoperability. What is missing there? What is that we need in terms of standardization today?
Yeah, standardization is we think is a very important part for the whole MEC technology to be adopted widely. And there are different areas, I think, where standardization is required, but there may be some other areas where we can leave it open for implementation. For example, if we see at the MEC technology itself, it's a combination of two different technology. One is the networking technology, and then there is what is called the IT, or information technology. So, now, from the networking technology perspective, a MEC platform has to be connected, say, within the core network or the access network. So how do we connect that MEC platform to an operator's network? We may need to standardize that interface. Otherwise, the operators will be stuck to a particular vendor if it's a proprietary implementation. Then also, we may need to standardize how a MEC platform will collect the network information from the network. So what kind of information can the platform collect is also a candidate for standardization. On the other side, if we look at the IT side of the MEC technology, we may need to standardize how an application can be run on a platform. So what are the APIs that it will need to see what are the services the platform provides? And by standardizing those APIs, what we are doing is we are enabling all the developers to come up and write application for this platform. So that is also a very important part of the standardization. But again, what we can leave for implementation is how does the application provider eventually reads the data, say, process the data, and how it uses. Those are definitely not what we plan to standardize.
Right, and so the standardization process is going to create a foundation for the creation of an ecosystem in which mobile edge computing, all the different initiatives can actually be deployed. What is InterDigital doing in terms of creating or helping to create this ecosystem?
Okay, so we first of all believe that the creation of the ecosystem is very important, and the way to do this is coming up with first of all participate in the standardization, of course, and then coming up what we call test beds and proof of concepts. So at least we at InterDigital have developed a proof of concept, and which is available in the Etsy POC zone, which is FLIPS-based technology, which is the POC that we have developed and has contributed in the POC zone. We also actively participate in a lot of these consortiums where we contribute towards building a test bed to evaluate the MEC technology. And what we think, if we look at the standardization work that has been going on in HC-MEC or the other consortiums, we see that these consortiums and the standard organizations are kind of developing these APIs that I just mentioned about how to allow application developers to come in and build applications for the platform. If we look at HC MEC's phase 1 work till now, we see that there has been APIs that has been defined already, which will enable application developers to build and run their applications. We have also seen there is like like I would say right now standard compliant, but a lot of vendors are coming up with platforms that support this kind of running of applications. So we believe that in the near future, with the standardization of these APIs, this development of these test beds, this proof of concepts, we will see a more development and growth in these in the MEC ecosystem.
Right, and now if you look at sort of in the future, there is sort of an ongoing debate here in terms of what is 5G going to be, what is going to be the relationship between 5G and MEC. So you can argue that we need to wait for 5G, or that the MEC is part of 5G, or is it independent and just moving in parallel? What do you think?
Okay, so this is very interesting. Like we see a lot of like reference from between MEC to 5G, 5G to MEC. But what we have seen today, that MEC is being even deployed in 4G networks to offer innovative services and enhance user experience. But what we think is MEC really hits its potential with 5G, and 5G will hit its potential with MEC. They complement each other. So for example, like MEC is the very foundational element that will allow 5G to live up to its potential. Now, we can look at the IMT 2020 5G use cases triangle as a reference, where we see MEC is a foundational element in a lot of the ultra reliable low latency communication vertices. And there's various use cases that has been described there. For example, connected gaming, cognitive assistance, industry automation, mission critical applications. So without MEC, this kind of low latency requirements cannot be made. So we see 5G use cases that relies on MEC's ability to provide low latency. And on the other side, if we see like MEC, the main information or the main utility that MEC provides is this network related information. And what we see in 5G allows or provides different kind of network informations or makes it available. So that's why we also believe that MEC will benefit from the 5G deployment.
Absolutely. So that's an interesting view. They both need each other, but they can both progress at their own pace. So you don't have to stop and wait for 5G to arrive. Now, another technology or another direction in our industry that is relevant to MEC is virtualization. It's difficult to think of mobile edge computing without some level of virtualization, because that allows you to actually move things to the edge, or makes it easier. What do you think that the relationship is there? Is that another complementary type of relationship?
Right. So if you think MEC is, as I mentioned before, is a combination of networking technology and information technology, or rather cloud technology. And if we talk about cloud, virtualization and use of virtual machines comes in automatically. So yes, so in at least from in the HC-MEC architecture, reference architecture, we see this virtualization of this MEC platform has been described there. And we also see HC-MEC is actively collaborating with another HC group called HC-NFV. So that's also a group which is actively involved in network function virtualization. So To enable cloud resources at the edge, we definitely need virtualization techniques. But what we see is it's not only the VM or the virtual machine technology that will enable or make MEC successful. We need to also look into the other technologies that are available. And right now, one of the example I can say is like containers or microservices. So those also enable virtualization, but they're different from the virtual machine concept. So what we see is those will also come into picture as MEC gets deployed into multiple use cases.
Right. So now we've been talking about the edge as if we know what we're talking about, but there are different definitions. Where is the edge? Because you can argue that the edge is at the node B, the antenna, and the south side, or it could be an aggregation point in the CRAN. It could be in the device. So where do you think is the edge, or is there one edge?
Right, you are absolutely right. We think edge can be like at a multiple levels of the network. Again, I will go back and say it really depends on the use case or the verticals that we are talking. Now, if we talk about, say, like ultra low latency use cases, like what in 5G URRLC, in those kind of low latency use cases, it makes sense for the edge to be placed what we call the leaf of the network, the utmost edge. It's not even E node B, it's maybe not even small cell. It can be the user device itself. Or in certain cases, for example, where ultra low latency is not required, but say we need a big amount of computing, it's okay to put the edge, say, at a 1 or 2 levels high in the network, maybe at the core network level, or in certain cases, it's okay to be at the distant cloud itself. So what we think it's based on the requirement or the verticals that we are considering, or where we want to apply the MEC technology, will decide where the edge is.
Mm-hmm.
And I think that's what is challenging. That's what is very challenging to identify. So as an application developer perspective, before writing down the code or developing the application, a developer needs to clearly identify where the application will benefit first and decide where it should be deployed to get the most to benefit out of the edge computing. And based on those applications, based on those requirements, the application will be deployed at a certain location in the network.
Right. So if we go back to, you mentioned there are different use cases. Can you give us a sense of what are the best use cases for mobile edge computing, and how do they relate in terms of where do you put them? Where do you put them in the edge?
Right. Okay, sure. Yeah. So for example, as I was talking, and I will refer to 5G terms like the ultra reliable low latency communication, that is URLLC. So in those cases, we see applications like connected gaming, cognitive assistance, autonomous navigation for self-driving cars, or even drones. So those use cases where we need really low latency, we think it would be beneficial to put the edge at the very, or what we call the far edge, maybe in the small cells, or maybe in the access points, or even certain part of the edge resources can be put in the device itself. But whereas in the other cases, for example, like a photo editing application, or an OCR kind of application, it may not be required to put maybe in the device itself, or we can put it into, say, within the network, say at the one level high in the aggregation, say E node B, or maybe at the core network level. So those kind of services where ultra low latency is not required, we can put them inside the network at a certain levels higher there.
Yeah. Well, okay, let's just look at the business model too. There's an increasing, now that we know where MEC is going, the question that operators are asking is who's going to pay for it, because that might add cost to the network, to the operators. Are they going to pay for it, or is content providers, the enterprise, venue owners going to pay for some of this infrastructure?
Yeah, that's very interesting. And what we think, the whole business model is still evolving. The industry doesn't have a clear answer. What's the business model? Who pays for MEC? For example, what we think is the first adoption of MEC will be really driven by enterprise customers, because they have necessity to deploy MEC to support some of their applications like industrial IoT or surveillance, or some of the sporting events, like how the recording or the content that is generated and how it is distributed. So those are the use cases for MEC that we see is being deployed initially mostly by enterprise customers. Now, moving beyond enterprise customers, when we think about use cases where it involves end users and the network operators, it's a very I would say the question which is still not clearly answered: who pays for that? Network operators may deploy MEC with the view that they will be able to generate additional revenues, and that will come from, say, the users or the application developers. So because they are providing certain services in terms of they are providing network information, they are providing computational capability, and that will allow them to generate revenues. But on the other side, for example, users may not be willing to pay because from their point of view, it is a problem of the network operators they're trying to solve by installing MEC platform. So that is an area which is still not clearly defined, but we think it will be driven by, I would say, how successfully MEC platform can solve those problems of latency, computational capability. If we see that those are really improving the performance of the applications, so maybe users may come in and willing to pay for those value-added improved services.
Mm-hmm. Yeah. Well, this is so very interesting and exciting. Can you tell us what you're working on right now in terms of the next 5 years, or where do you see the industry going in the next 5 years?
Sure. From our company, what right now we are working on, like thinking that from the edge computing perspective, as we have said, that we are still debating where exactly the edge is, whether it is at the core network, or is it at the eNode Bs, or is it the devices. But from our perspective, we think as of now, we will be benefited by, at least by pushing the edge to the very far of the edge, very far in the network. And we are very much interested in enabling applications that will require this far edge MEC support to enable low latency use cases. So what we are working on right now is building a platform which will enable or include these far edge MEC platform, which may be running in all those far edge devices. When I say far edge devices, I mean it can be a small cell, it can be in Wi-Fi access points, which will not need, say, any additional or extra computational infrastructure. Whatever computational capability those devices have, we'll try to use those and, say, provide MEC services. So we are planning to build a platform which will be applicable or may be used across all these different devices and enable application developers to write one single application for all such multiple devices.
So basically, this is a new way to think about how to develop applications. So you're enabling a different way of, for the application provider developers to actually implement them and design them, right?
Yes. Yeah.
Okay. Well, Debashish, thank you so much for sharing your thoughts with us today. It was a pleasure talking to you.
Thank you very much.
And this conversation is a part of a report on mobile edge computing and pushing the functionality to the core, to the edge. or functional to the edge. And I would like to thank you all for listening in. And the report is available on RCR Wireless News and Sensafili website. Thank you all.